Hi and a very good day. So in this video session, I will discuss the fundamental concept that relate to the theory of time series model, which is a stochastic time series. Okay. So for this topic, I will discuss 5 important concepts, which are stochastic time series, stationary time series, non-stationary time series, stationary testing, and lastly I will discuss about forecasting under stationary and non-stationary. Okay, right. First, let's discuss about what is the definition of stochastic time series. Okay, so for stochastic time series, let's say that we have a sequence of observation. Okay, a sequence of observation, and we want to view this observation with the element of probabilistic. Okay, and we define this observation as sequence of random variables. All right, since that we discussed about the probabilistic term, now we have to determine the distribution of our random variables. All right, so the difference between time series and a cross-sectional data, instead of we discuss the probabilistic properties in terms of an observation at one point with different subjects such as country, firm, household for cross-sectional, but for time series the random variable is in a sequence. So each of the random variables probabilistic character may depends on each other, right? So the process here is represented as as this. Okay, so we say that it is a series of random variables. Okay, so when we talking about the stochastic series, the complete probabilistic structure of such process is determined by the set of distribution of all collection of the y's. Okay, so that's why we call it as a stochastic process. Okay, right, so let's take a look at another point. Okay, so we say that the observation of this time series is what we say that is to be one realization of a stochastic process. Okay, so what is the meaning behind the realization of a stochastic process? Okay, suppose that this is our observation generally. Okay, suppose that now, as example here, we have t at 1, 2, 3 and so on as example, and we want to measure maybe, okay, so as example, consumer price index at t1, t2 and t3 as example. So we have the value here as example. Okay, now suppose that we take this this CPI as y. Okay, so this y3 is the realization at t. Okay, EY3 is the realization at t equals to 3, meaning that the realization means that under a good economy or bad, we actually have several possible value here. But instead of that, we say this 95 here is the average of the expected, or the average of possible value at this particular as t equals to 3. Okay, so that's the meaning behind the realization of the series. Okay, and of course, when we modeling the time series, we want to describe the probabilistic behavior of the underlying stochastic process where we believe it generate the observed data in a concise way. Okay, and okay, let's take a look at the properties of stochastic time series. Okay, for stochastic properties, it means that okay, our stochastic process may have this particular function. Okay, a first mean function defined by the expected value of yt is equal to mu t. Okay, mu t is the expected value of the process at time t and may be different as each time point t, where the variance function of yt is equals to okay sigma square at time t. Okay, and this is particularly the most important concept in stochastic time series, the autocovariant function. Okay, where the autocovariant function is defined by the okay the covariant okay between point t and point s. Okay, so this autocovariant function in a given stochastic process is the function that give the covariant or measure of the joint probability of two random variables of the process with itself at pair of time t and s. Okay, based on the autocovariant, we can define the autocorrelation function. Okay, as we can see here, this is the autocorrelation function, and this autocorrelation function also known as serial correlation. Okay, the correlation between the element of a series given the different time period of t and s. Okay, based on this autocorrelation values, okay, we say that it will give the it will give us the idea how our observation depending towards each other. Okay, so the value here indicate the magnitude of the dependency among the observation. Alright. Okay, for the I think that's all for this video. I will continue in the next part of video. Okay, so thank you for listening.